All right, hello everybody. So, thought we would start with inverse trig functions, and these are functions that you actually have used before, maybe in geometry. Say, I had maybe a right triangle like this. Actually, we've used them here in this course as well. And maybe I want to find this angle theta, and I do something like sine theta is equal to 3/5, and then to find theta, I do the sine inverse of that and it popped out some number, and I never really talked too much about, okay, what is that number? Are there any restrictions on what number is outputting? And it turns out that there are. We just kind of skimmed over it to start with. There's domain and ranges for this sine inverse, so I can't plug every number in here. My domain's kind of restricted, and I'm not going to get out every number either. So, and that comes back to the graph of the sine not being one to one. It's got to be restricted in order to have an inverse. Um, I would talk more about that, but I don't want to burden you down with so many details right now. I just kind of want to get to the main point, okay? And the main point is going to be these three functions. The inverse trig functions, you really need to know what the domain and range is for all of these, and you need to know how to compute with them, okay? So for like y equals sine inverse to x, your domain is negative 1 to 1. So right there, that means that if I'm doing something like sine inverse of 2, yeah, I'm going to get an error because 2 is not in the domain of sine inverse. Okay? Um, Range, I'll talk more about what this is meaning, but the output, the y value, has to be between negative pi over 2 and pi over 2. Cosine inverse, domains between negative 1 and 1, ranges between 0 and pi, inclusive. Y equals tangent inverse of x. The domain is all real numbers, negative infinity to infinity, and your range is negative pi over 2 to pi over 2. Notice that this one is non-inclusive, so negative pi over 2 and pi over 2 cannot be outputs, but anything in between those two values can. Okay, I would write those down to start with, and then we're going to do some problems. So pause it if you want. And then while you're doing that, the next thing that you're going to want to do is get out your unit circle, okay? Or if you don't have a unit circle, get one, because you're going to need it for this section. You print one off or have one on your phone off to the side or something. Okay, so you have all those written down. And then pull up this unit circle. I thought somebody was standing out here. It's like late at night, and that was scary. It's not a ghost. I think it was my reflection, right? Seriously, creepiest thing I've ever witnessed. Okay, scared, but continuing. Ghosts need math too, I guess. So our unit circle, the only change that I would make here, and this was the unit circle that you probably printed off. When they use like 11 pi over 6 and 7 pi over 4, really we need to add a few angles down here in this fourth quadrant. So because our ranges was like negative pi over 2 to pi over 2, it doesn't help me too much to think about 3 pi over 2. This is coterminal with the angle negative pi over 2, just because I could go, clockwise, and that's a negative angle. This 5 pi over 3, instead of thinking about it like that, I would think about it as negative pi over 3. Instead of thinking about 7 pi over 4, I think about negative pi over 4. Instead of thinking about 11 pi over 6, I think about negative pi over 6. So go through and add all those values to your unit circle. Okay. And then I want to go through and just do some of these. So y equals sine inverse of 0. So what this really means, and I'll say it a bunch of times, and if you're Now understand, go back and watch it a second time because it's going to click. I want to find the angle that gives a sine of 0. That's what that means. Sine inverse of 0, I want to find the angle whose sine is going to give me 0. Right? So what angle has a sine of 0? But the one twist is that because this is arcsine, that output, that y value, the range, has to be between negative pi over 2 and pi over 2. So really, instead of just finding I want to find the angle where the sine is 0, I really want to say find the angle between negative pi over 2 and pi over 2 where the sine is 0. So I'm really looking at this part right here. What angle between negative pi over 2 and pi over 2 gives me a sine of 0? And we're always working in radians. And probably not a great example. I guess I should amend this to also have a 0 radians, because that's 2 pi as well. So what I'm actually looking for on this one is 0. That's between negative pi over 2 and pi over 2, and the sine of 0 is 0. So this is 0. Okay, so that's our answer. Just box that off. Okay, let's look at another one. Let's look at another sine inverse one. Sine inverse of negative 1. Okay, so what angle gives me a sine of negative 1? What angle between negative pi over 2 and pi over 2 gives me a sine of negative 1? So the angles between negative pi over 2 and pi over 2. Which one of those angles gives me a sine of negative 1? That's going to be this guy down here, negative pi over 2. Looking at some more. What about if I did this guy? Y equals arcsine of negative radical 3 over 2. So for this one, we're thinking, what's the angle between negative pi over 2 and pi over 2, where the sine is going to be negative radical 3 over 2? Okay, sine, that y coordinate's negative radical 3 over 2 here. So the angle between negative pi over 2 and pi over 2, that gives me a sine of negative radical 3 over 2. That's going to be this negative pi over 3. Now, you may notice that if you're in if you have a calculator, you can also put this in a calculator if you're in radian mode. And depending on the calculator you have, it may or may not give you the exact answer. But what I'm looking for is the exact answer. But if it doesn't give the exact answer, it'll give you some decimal, and you can kind of verify your answer and check it that way. Okay. So notice here is arcsine. That meant the exact same thing as this. So it's just kind of them throwing in a different notation, and it didn't change anything, right? Should we look at some more of those? Maybe one more with the arcsine. All right, how about this one? So y equals arcsine of, let's say, negative radical 2 over 2. Write down what you think that one would be. Yeah, so you're thinking of angle between negative pi over 2 and pi over 2, where the sine is going to be negative radical 2 over 2. That's going to be negative pi over 4. Now, what happens if on this problem I had said, okay, well, it's 7 pi over 4. Mr. Foreman, it can't be wrong. It does give a sine of negative radical 2 over 2. Yes, it is wrong, because that is not in the range for arcsine. Remember, our range for arcsine was between negative pi over 2 and pi over 2. It's what I wrote up here, right? So like 7 pi over 4 for this one, if you wrote that, incorrect. So I really got to pay attention to the domain and the range, particularly the range. Okay. All right, and then let's do some with cosine. So let's do y equals cosine inverse of -1. Now, for cosine, your range is different. So for cosine inverse, your range is between 0 and pi. All my outputs are going to be between 0 and pi. Whereas for the sine inverse, they were between -pi/2 and pi/2. For cosine inverse, they're between 0 and pi. So if I'm asked, something about cosine inverse, the angles I'm looking at are in quadrant 1 or 2 right here. Whereas if I'm asked something about sine inverse, the angles are from -pi/2 to pi/2. If I'm asked something about cosine inverse, my angles I'm looking at are from 0 to pi. So there is a difference there. What are we looking for here? We're looking for what's the angle between 0 and pi where the cosine is -1. So that would be this angle here, pi. Cosine of pi is -1, right? So that's going to be pi. And that is in the range at the tail end of it. Point that out as well. Okay, what about this guy? Cosine inverse of, let's say, -1/2. So what angle between 0 and pi gives a cosine of -1/2? So cosine is going to be -1/2 here, and that's at our angle of 2 pi over 3. And that is between 0 and pi. Okay. Let's look at another one. What about this guy? Arc cosine of, say, 0. You can try that one if you want. What's the arc cosine of 0 going to be? Yeah, so the angle between 0 and pi that gives a cosine of 0, that's going to be pi/2. Remember, this notation means cosine inverse. Okay, so hopefully that's good for arc cosine, cosine inverse, however you want to say it. Let's also look at some with tangent inverse or arctangent. Okay, so last type. And let's do like tangent inverse of, say, 1. This is a really important value here. And remember, your range for your tangent inverse, that's between, -pi/2 and pi/2. Now, tangent values aren't on the unit circle, but I do want to just point a few that are, important ones here. If you're thinking about what's the tangent of pi/3, for instance? Well, we worked with that a lot, but we thought about it in terms of degrees, right? We thought about it in terms of this picture, 30 degrees, 60 degrees, where opposite angle, 30 degrees opposite to that was 1, opposite to 60 degrees was √3, and then opposite to this was, 2, right? So we did a lot with that early on, where we said, okay, tangent of 30 degrees was opposite over adjacent 1 over √3, right? Which was √3/3. That really means we know the tangent of pi/6, which is 30 degrees, is √3/3. We also know that from this, y divided by x, sine divided by cosine, if I do 1/2 divided by √3/2, notice I get 1 over √3, right? So in a whole slew of ways, I know that the tangent of pi/3, that's √3. Tangent of pi/6, that is √3/3. Tangent of pi/4, that is 1. What's the tangent of 0? Well, 0/1, that's 0. Really, it's undefined here. Now, I hate to use the word common sense because I don't have any common sense, I'm told, but this is common sense, right? You look at this. You look at the y and the x values, right? Like, what do you think the tangent of 5 pi over 6 would be? Just kind of by the symmetry. It's going to be like negative root 3 over 3, right? The only thing changing is that negative sign. Other than that, the point's the same. What's like the tangent of 3 pi over 4? That's negative 1. What's the tangent of 2 pi over 3? That's, negative root 3. Really, these are like the only 4 possibilities. What's the tangent of negative pi over 6? Well, kind of looking at this, that would be negative root 3 over 3. What's the tangent of negative pi over 4? That's negative 1. Right? What would the tangent of negative pi over 3 be? That would be like our negative root 3. Okay, if you have to write them down, think about them. But I don't think it's too bad. You're just kind of looking at the unit circle and figuring it out. Or you can think about it with this reference triangle. Okay. In fact, I think I will go ahead and just write these off to the side here. Tangent of negative pi over 6, that was negative root 3 over 3. You can calculate that by looking at y over x. Tangent of negative pi over 4, that was negative 1. Y over x is negative 1. And tangent of negative pi over 6, that was negative root 3. So if you do want to write those down, you can. Okay. So like this one, back to this. Angle between negative pi over 2 and pi over 2. So here we're looking from here to here, right? And when is the tangent 1? Where the only place where the tangent would be 1 would be this angle of pi over 4. So this is pi over 4. Okay, what about arctan of 0? So what's the angle between negative pi over 2 and pi over 2 where the tangent is going to be 0? That's the only place where that happens is right here. So this is 0. And, okay, one more here. I'll have you try this one here. What is the arctangent of negative 1? Yeah, it's going to be negative pi over 4, right? So the angle that gives a tangent of negative 1, that's going to be negative pi over 4. Okay. So that's the key part. Being able to evaluate just expressions like this with the unit circle, knowing your domain and range for your inverse trig functions. Okay, so that's key. And that's what this first video is about. Now, this is really the exact value. If they say the exact value, they're talking about a real number, they're talking about radian. I might just want to point out that they can also do something like this. So let me just throw one more example. Give the degree measure. And this would literally be the only time you write the angle in degrees, is if it said that. If it just says find the exact value, you're thinking in radians. So this is the only time where I give out a degree measure. Say I had like y equals sine inverse of, let's do root 3 over 2, right? So remember, we'd recall the range for arc sine. So that's between negative pi over 2 and pi over 2. What's the angle that gives us sine of root 3 over 2? That would be this angle pi over 3, right? That's between negative pi over 2 and pi over 2. So that would be pi over 3. However, I just wrote the wrong answer. See, I always think in radians. Let's see, here this said degrees. So instead of writing pi over 3, on that one I would want to write 60 degrees. And use the degree measure instead of the radian measure. But that would be the only time. Okay, if they say find the exact number, yeah, our answer is pi over 3. Or say find the real number. Okay? Answer is pi over 3. Okay? hope that makes sense. Only if they say find degree measure, then I'm doing that. Alrighty.